Question 20. Triangles ABC and DEF are mathematically similar. The base AB of triangle ABC has a length 2 lots of x minus 1 centimeters. The base DE of triangle DEF, the large triangle, has a base of x squared minus 1. The area of triangle ABC is 4 centimeters. The area of triangle DEF is t centimeters squared. Prove that t, the area of the large triangle, is x squared plus 2x plus 1. So if these were all numbers and not algebra, we would have to find out the scale factor by dividing this one by this one. That would tell me how many times larger this is compared to this. Then we know that the area for the small one is 4, but just because, let's pretend this was double the length of this, so the scale factor is 2, that doesn't mean the area is just doubled. It's actually 2 squared, as it's an area. So if the scale factor was 2, so twice as large for the base, that means the area would be 4 times 2 squared, okay, to find the area of the large one. So let's get started then. So first of all, we need to find out how many times bigger this is compared to this. So that means we need to divide this by this. So the scale factor, first of all, is going to be scale factor equals x squared minus 1 divided by 2x to the minus 1. Now, we can factorize this into x plus 1 x minus 1 over 2x minus 1, like that, and that means that bracket times this bracket divided by 2 times this bracket. So as we can see 1 on the top and bottom, we can cancel those out, which leaves you with a scale factor of x plus 1 over 2. Okay, so first of all, the scale factor is this. Now what did we say after that? Now we've worked out how many times bigger this is compared to this. We know that the area of the big triangle is going to be 4 times the scale factor squared. So the area of the large triangle is going to be the area of the small triangle, 4 multiplied by the scale factor, which is x plus 1 over 2 over 2 squared, as it's an area. So this is the area of the large triangle. Now that means A equals 4 times x plus 1 multiplied by x plus 1 over 2, step at a time. So that means it's going to be 4 times x plus 1 squared over 4, and we can cancel out those 4's to leave us with the area of x plus 1 squared, close brackets, then squared. And if we multiply that out, I hope it's going to get us to this, x squared plus 2x plus 1. So the area is going to be x squared plus 2x plus 1. So t equals that. So have we proved that that is that? Yes, we have. And that is definitely an A-star question. Okay. So question 20 is worth 4 marks. Now before I do that, I just want to explain why this bit was the scale factor squared. Okay. So let's take a normal square and let's pretend that the square is 2 centimeters by 2 centimeters. So if the square was 2 centimeters by 2 centimeters, I hope you would agree that this is 4 centimeters squared. Now let's enlarge that by a scale factor of 2. So that means now the sides are 4 by 4, which would give us 16 centimeters squared with a scale factor of 2. So we can't just because we times the sides by 2, the area is going to be 4 times 2 squared, okay, for a scale factor of 2. So therefore here we couldn't just times the area of the small triangle by a scale factor of whatever it is. We have to times it by a scale factor of whatever it is squared to get us the area of the large triangle. Okay, and so we end up with x squared plus 2x plus 1, which is what the question's asking. Okay, so question 20 is worth 4 marks. The mark scheme says the first mark is for finding a scale factor. Sorry, the first mark is for that, for seeing this, for dividing the big base by the small base, which we've got here. The second mark is for then cancelling, expanding this, factorising this and then cancelling it down to this. Or you could have got half open bracket x plus 1 close bracket as a scale factor, same thing. The third mark is then for trying to find the area of the big triangle and realising that's going to be 4 times the scale factor squared, which is here. And the fourth mark is then, or this here, whichever way you do it, to get it to equal this, to prove that t equals x squared plus 2x plus 1. So that's the fourth mark, and that's question 20.